lifting a glass of water. It looks simple, but in reality, it's an extremely complicated process. Eyesight, the hand, movement, and planning must all be able to work in synchronicity. Researcher Erik Domellöf's interest is in how we as children learn to plan our movements.
The main objective is to investigate the development of motor planning ability in children from preschool age to early school age. And it concerns both children following a typical developmental trajectory and children with autism spectrum disorders.
Planning our movements is important all the time, whether we're walking, eating, playing, or working. It's not something we think about, it just works. It is a synergy between the movements of the body and brain activity. But what happens when this motor planning falters? Could this even affect how we behave with others?
Hej! Erik heter jag. Välkommen. Välkommen.
Here at Umeå University, Erik has started a research project in which he measures the motor planning skills of different children. He's built his own lab with video cameras for motion measurement. Here, he can follow the movements of the children as they perform predetermined simple tasks. Today, it is 8-year-old Alia's turn.
Så vad kamerorna gör är att de tittar efter mitten på den här bollen.
Erik explains to Alia how the sensors work.
Så.
In addition to recording the hand movements, Erik also wants to be able to follow the child's eye movements in order to understand how the child looks in order to plan her movement.
Eye movements are important to study because they are an important part of the motor planning performance. When performing a goal-directed action, the gaze is before the hand. När du ser att den här lampan tänds.
When the lights turn on, Alia will move the stick toward the target.
Okej, är du redo, Alia? Despite the fact that it's a very simple movement, there are many things that you can study. One, where you transport the hand to grasp the peg, and one, transporting the peg to the goal.
Between each attempt, Erik changes the objective.
And this goal is then a second-order goal for the whole movement. And we are interested in how do children rotate this peg? Do they do it in their hand or will they have to use the whole arm or the body in order to perform this?
These children will then come back and do the same test over several years so that he can follow their development. Within the project, Erik will also follow children who have problems with their movements, like some children with autism.
And this could have to do with problems with motor planning. And if you do have problems understanding your own actions, then you might have problems understanding the actions of others. So it might tie into also problems with social functioning in these children.
This can be revealing in the motion test, that children with autism take on the task in a different way. Instead of seeing a single fluid move, they divide it into two separate moves. One to grab the stick, and one to put it down.
The effect could be that the movement is more awkward and less efficient than if you had actually planned the whole movement from the very beginning. And that could lead to that the movement appears more clumsy.
A short walk away from the university is the hospital.
Vad ska vi göra här?
Here is where the next part of the research project happens. Here, the children get a brain scan. The scientists believe that differences in children's ability to execute motor planning can also be seen through differences in brain structure.
We hope to find that differences in the structure and the organization of the brain is perhaps related to differences in the execution of movements requiring planning. And this is, of course, particularly interesting in regard to children with autism.
The brain pictures, along with the movement tests, will provide new knowledge that can help children with poorer motor skills, like some children with autism. Erik is planning to develop customized exercises, perhaps as a video game, that can improve the motor planning ability of the children, and which can also positively influence the brain.
One ultimate goal is to see if training motor planning ability could have a positive effect on motor planning execution. And for example, it would be fantastic if we can find a training method that can help children with motor planning problems to function as optimal as possible in their life. Snyggt jobbat, Alia! Hur kändes det där?
Jätteläskigt.
Ja, men du var jätteduktig. Du klarade det superfint.